Welcome to this lecture series in coordinate geometry. In this lecture, we'll just solve a very simple problem just to illustrate whatever we have learned. We need some very basic knowledge of geometry. We need to know what is meant by equation of a line, how to form an equation of a line, which we discussed at length. And we need this fact that if we have two lines L1 and L2 with slopes M1 and M2, none of them are 0. Then these two lines are perpendicular if and only if the product of their slopes is -1. It's a very simple fact. You can prove it immediately even if you do not recall the proof. We discussed this. Alright, so here is the example or problem that I want to discuss. We have this point 3, 8 on the plane, and we have this line on the plane which we have drawn. So this is the point 3, 8, and this is the line x plus 3y equals 7. What we want to do is, we want to find the reflection of this point about this line. So think of this line as a mirror and just reflect this to get the reflected point, and we need to find the coordinates of the reflected point. Okay, so basic geometry tells us that whatever is the let me first draw something. So what we will do is draw the line perpendicular to the given line passing through the point 3, 8. So if we do that, we get, something like that. So this is the line perpendicular to the given line passing through the point 3, 8. By reflection, we just mean whatever is this distance, mark out the same distance from this point of intersection and locate this point. So, in other words, the reflected point is whatever, but the midpoint of these two is the point of intersection. Alright, so once we locate this point of intersection, we should be able to locate the required point, because the midpoint of these two is the point of intersection. And we will locate the point of intersection just by writing the equation of this line and solving these two lines simultaneously. That is basically it. So let's do that. So first of all, what is the slope of this line? We know the slope of this line, which is non-zero, and therefore since these two lines are perpendicular, the slope of this line can be calculated. So what is the slope of this line? The slope of this line is -1/3. Therefore, slope of, let's call this L, slope of L is 3. We just use the fact that the product of slopes of two perpendicular lines is -1, provided none of the slopes are 0. So the slope of this is 3, and we already know a point through which this line passes. So the equation of L is y minus 8 divided by x minus 3 equals the slope of L, but the slope of L is 3. So therefore that is the equation of this line, which is same as y minus 8 equals 3 times x minus 3. So that is the equation of this line. I shouldn't say this is the equation because this does not account for the point 3, 8. You cannot substitute x equals 3 here. So this accounts for everything except the point 3, 8. So this is really the equation of the line. And now we just solve this and that simultaneously. So y minus 3x equals 8. So that is basically it. And I hope I'm not making a mistake. Yeah, so if you solve these two equations, meaning this equation and that equation, you get that, let's call this x0, y0. So you get x0 is equal to let me see, I had pre-computed it. X naught is equal to 1 and y naught is equal to 2. So that is what you get. So once again, what did we do? We just wrote down the equation of this line. We wanted to find this point, and to find this point, all we need to do is solve this linear equation simultaneously with that linear equation. And if you do that mindless algebra, you get that this is the solution. So this point we already know. And now what we really wanted to find out was not this point, but the reflection of this point about this line. So let's call that reflection alpha comma beta. Let me maybe write it here, alpha comma beta. As we said, this is the midpoint of these two. So we have alpha plus 3 by 2 equals 1 and beta plus 8 by 2 equals 2. That gives us alpha as minus 1, beta as minus 4. So let me check with my calculations. Yeah, this is correct. Right, so that is the solution. This is how you can compute the reflection of a point about a line. So hopefully this was instructive. As usual, like, comment, share, subscribe, and I will see you next time. All right.